All right, let's go ahead and get started. So again, hello everybody, and welcome to today's webinar presentation titled Moving from a Relational Model to NoSQL, brought to you by Couchbase. I would like to introduce you to today's presenter, Matthew Groves. Matthew is a guy who loves to code. It doesn't matter if it's C#, jQuery, or PHP, he'll submit pull requests for anything. He has been coding professionally ever since he wrote a quick basic point-of-sale app for his parents' pizza shop back in the 90s. He currently works as a developer advocate for Couchbase. His free time is spent with his family, watching the Reds, and getting involved in the developer community. He is the author of AOP in .NET, a Pluralsight author, and a Microsoft MVP. At this time, I'd like to do a quick sound check for Matthew. So Matthew, please say hello to our audience, and audience, let me know if you can hear him.
Hi there. Thank you for the introduction. Can everyone hear me okay?
It looks like we're good to go, and we'd like to
Okay.
pass it off to Matthew for the presentation.
All right. Well, thank you very much. Thank you for that great introduction and welcome. Today, I want to talk about moving from relational database model, a data model, to NoSQL, and we're going to see how a flexible JSON schema fits into that. So my agenda today is I want to give you an overview of migrating from existing relational database to NoSQL, in my case, Couchbase. And we're going to look at migrating a database, but even if you don't plan to abandon your relational database completely, and you want to start with NoSQL on a greenfield project, this is still going to help you kind of compare and contrast NoSQL with relational as we go forward. So we're not going to get into really, really deep details like query optimization and indexing and things like that, but you will get a sense of some of the technical issues and differences as we go along, as well as some of the reasons why this might benefit your team, your organization. So this is my agenda for today. We're going to quick intro to NoSQL, quick intro to Couchbase NoSQL, and some migration options. And then I will have some optimization. We'll talk about what that means. And then I'll show you a quick demo of Couchbase in action. And if you have questions, as she said, go ahead and post them into the Q&A, the questions panel there, and we'll get to those as soon as we can. And if anything comes up along the way, I might just take that question during the slide. So we'll see how that goes. All right, so a quick intro to NoSQL. There are use cases out there where you need to track a lot of information. So for instance, let's think of an e-commerce website. Right? It's not just about tracking the purchase, right? Recording that a customer bought a purchase, but there's lots of other interactions that go into that. So what items did a user view in the catalog? What they add to their cart and remove from their cart for that matter? What kind of searches did they perform? Did they read reviews? Did they leave reviews? Did they ask questions? Did they add something to a wish list? It can be a really huge amount of data that goes into that one ultimate purchase or transaction at the end. So that's a lot of data that goes into that. And this is where NoSQL, I think, has traditionally come into play, is where you have an e-commerce site and you have all the considerations leading up to the purchase at the end. And the purchase is a relatively, small bit of transactional data, and everything leading up to that helps you guide the user towards making a purchase ultimately. And we can take that same principle and apply it to other use cases. So a supply chain where you need to build up the supply and all the steps that go along that path until you actually fulfill an order for someone purchasing supplies from you. Or even IoT, where you have all kinds of operations that go into recording data from IoT devices that lead up to a specific service that a user or a piece of software is wanting to perform. So we have, kind of an iceberg of data. We have the very tip of it, which is the transaction that everyone's trying to build toward. And under the waterline, you see this massive chunk of information and data that leads up to it. And that's where NoSQL has really been a great reason for people to start using it in the first place. Application requirements are dramatically different. between NoSQL and relational. So I'm going to call it transactional database. Transactional is kind of your traditional relational database. And then you have analytical databases that are for reporting or BI that you may copy data out of transactional into analytical to do that. And NoSQL, I think, overlaps these, and we can talk about how much it overlaps them, but it overlaps them definitely in cases where scale and flexibility and high availability and performance and can provide lower costs for those things, especially when it comes to storing all those interactions and that activity leading up to the ultimate transaction. Now, because the first generations of NoSQL, they didn't have anything like a join. They didn't have ACID transactions. They didn't have even obviously they're called NoSQL, didn't have a SQL language. So they don't really fit all those transactional use cases. But despite that, they're still very good at providing high performance and scale and high level of interactions. So for things like microservices, you could pick and choose which database to use for each service. Large scale, where just staying online and being able to handle a large scale is more important than things like joins and ACID transactions. IoT, of course, consumer-facing things. But the thing is, Couchbase is actually a mature NoSQL database, so it does support SQL with joins, and not just joins, but the full SQL language and ACID transactions. So we can start to see that NoSQL is gaining even more ground in terms of use cases, right? So it's not the case that we use NoSQL and we have to work around the fact that we don't have joins. We have to, jump through extra hoops. With Couchbase now and mature NoSQL, you can even you don't have to jump through as many hoops even to achieve that level of performance and scale. So just a quick intro to what that means. So NoSQL document databases, like Couchbase, Couchbase is a document database. They store data as JSON typically. This is different than relational databases because the data can be much richer. So you can store arrays and nested objects, sometimes called subdocuments, and you can store arrays of objects and so on. So it can be a very complex, multi-level structure of data. This is just a quick refresher slide on JSON, but chances are you're already using this at somewhere in your organization, maybe not in your database yet, but certainly on the web, in your applications through your backend and all kinds of other places like that. So why JSON in the first place for distributed data? Why store data as JSON? So for a distributed database, NoSQL databases are typically distributed. They live across a cluster of multiple machines. A key trade-off in order to accomplish that is to make each piece of data independent, so it's not strongly coupled or tightly coupled to a table or a schema. And that makes the distribution easier because I have 3, 6, 9, 12, whatever machines. That piece of data can live on any one of those machines. It doesn't have to belong to a table. So even though it's independent and it's non-relational, it still makes sense to put that into a helpful format. So why JSON? Because JSON is so widely supported by every language and platform that I can think of. And like I said, it goes beyond databases. It comes from JavaScript. So if you're using any JavaScript at your organization, even just a little bit, you're probably using JSON already. And this eye chart here on the right side of the screen that I don't expect you to read is a list of JSON parsing libraries by programming language. So you can see that there's hundreds of them listed there for any programming language. Even COBOL's on there. I think even Fortran is on there. So even COBOL and Fortran can work with JSON data. So let's talk about comparing and contrasting the relational data model to a NoSQL model. On the left side here, we've got a traditional relational database layout here. And a relational database contains tables, and tables contain rows. Now each row has to follow the spec, if you will, the schema of the table, and is, as I said, tightly coupled. It belongs to that table. On the right side, instead of a table, in a NoSQL, in Couchbase we call them a bucket, which is about the same level of hierarchy as a database or a catalog. Inside of that bucket, there are things called collections. And collections have, instead of rows, they have documents. So now these aren't just naming differences, right? These are underlying differences in how these work and the benefits and trade-offs to this. But this is a good place to start if you come from a relational background. And you know, most developers I meet who work with data certainly have worked with relational in the past. So it's just kind of a way for us to start and kind of think about things in the same framework. So here's just a small example of the difference here, is that a NoSQL database and a relational database have different levels of schema enforcement. So a relational database is going to have a much stronger, rigid enforcement of the data, whereas a NoSQL database is going to be, you know, it's still some enforcement, right? It still has to be valid JSON, but it's going to be a lot more flexible in what you can store in each document. So just on the left here, we've got every row in the product table. It must have a value, even if it doesn't make sense to. So in the product catalog, quantity might not make any sense, but since it's relational, something must be there. So maybe we have to have something like a null or a magic number like 0 or -1, for instance. On the document side, we can just not have quantity in a particular document if it doesn't make sense to. So you can see there, it can just, it's not like it's null or empty, it's just not there. Now on the flip side of that, if I want to add a restock value, I need to add a column, and again, a value for every row, even if there's an item where restocking makes no sense. You know, it doesn't make sense to have a stock of a particular digital item, for instance. So, but I still have to have a restock field on there. On the document side, I can add a restock field to a single document when it makes sense to, right? So does it make sense to have a restock flag here? Then add it. Otherwise, we just omit it. And so this is just a small taste of this schema flexibility that's afforded by a NoSQL JSON document databases. This has made document databases a great choice for content management, catalogs, IoT, as I mentioned earlier, use cases where there's a lot of data and a lot of variation of data. Now, the trade-off here is that the schema is not enforced. So at least not at the database level. So in many organizations, this can actually help with agility. So it's no longer an interdepartmental memo, for instance, to get field added to the table. And DBAs can spend a lot less time on this kind of, you know, paperwork, pushing stuff around, and they can spend more time, you know, being proactive in their database administration. Just as a for instance, if you have an organization like that. I know I've been in organizations like that in the past. There's a question that came in here. I think it's okay for me to answer these as we go, because it is a relevant question. So in queries, how do you refer to elements or fields that are not there when setting up filter predicates? It's a good question. And I'm going to spend a little bit of time talking about querying of NoSQL databases later on, but I will say there's just some additional syntax. And in Couchbase, it's missing. So we can say where restock is missing or where restock is not missing, for instance. And that can help us find documents where those properties are there or aren't there. And that's actually very important for indexing as well, because indexes, we can create indexes like we can in relational databases. And I said I wasn't going to get into indexing detail too much, but I'm doing it anyway, so sorry about that. But our indexes need to know, a query needs to be written in such a way where the index knows that, okay, this field's not there, so I can skip looking for it. And so that's a very important thing when we're writing indexes later on. So really good question there. Thank you for that one. Okay, I'm going to go into Couchbase now. So Couchbase is a NoSQL database. And this is a diagram of Couchbase. So we've got our solid red core there that everything else in Couchbase has been built upon. And the things that we provide in Couchbase are kind of our pillars of why we build Couchbase the way we build it is for these 3 reasons. So we've got agility and versatility for developers. So I keep mentioning JSON, but actually Couchbase is a multiple model database. Everything can be stored as JSON. It can also be stored as a plain key value with an opaque value if you want to. When you have JSON, you can open up a lot of extra functionality. So you can see on here we've got a full text search and query, and those things work on JSON values. It's memory first, so it's a built-in cache layer. You don't have to duct tape a second or third technology to this to get caching. ACID transactions are in there. Both operations and analytics workloads are in there. And SQL is the language of Couchbase. You know, for some of you who have not heard of Couchbase before, yes, you can actually query your NoSQL data with SQL. Performance is something that Couchbase is very much focused on. So scaling is an important issue there. And Couchbase is a very efficient shared nothing architecture, so that it very efficiently scales out. Every single node in that cluster can handle, you know, a portion of the read and writes. It's not just a single sort of proxy or like a primary secondary system. Every single node can handle the reads and writes. Replication is built in as well. So if you want to sync data between data centers, between clouds, whatever you want to do, that's built right into Couchbase. Very easy. And so you can globally distribute it as well. You can have a data center in the east, data center in the west, and sync between them with the XDCR capability, the replication. And making it easy to manage is important to us. So we've got some ways to isolate workloads with multi-dimensional scaling, so that, for instance, if I have analytics set up, I don't want those complicated BI queries to affect the operational performance of the database. So there's some ways to isolate that workload. Same with query, same with search, so on. It's also Kubernetes friendly. We have a Kubernetes operator. We're the first NoSQL database to release a Kubernetes operator and make it generally available. We have automatic rebalancing, so automatic sharding. You don't have to worry about setting up efficient shard keys and worrying if you got it right, or setting up partitions. That's all done automatically. And I'm going to talk about Couchbase Cloud later, but you can actually deploy Couchbase anywhere you want to, your own data center, public cloud, private cloud, Kubernetes clusters, VMs, whatever you like. And you can have a hybrid model set up with that as well. So I really just want to say that Couchbase is kind of the best of both worlds here, between NoSQL and relational. So you've got all these things here, all these features of a NoSQL database that you would expect, and then maybe some more that you wouldn't expect as part of the NoSQL database. So key value for fast lookups, full text search built in. You don't have to, again, no need to duct tape a separate tool onto this. Memory first, shared nothing, so low latency and easy to scale. Asynchronous, so you don't have to wait on the disk if you don't want to. You can if you want to, but you don't have to. And masterless. And then the best of relational world, which is SQL, the language of data, most popular language to deal with data, and ACID transactions. If you have 2 different pieces of data or more that need to be updated together, you can throw that into an ACID transaction. And that'll work across a distributed architecture. And indexing to go along and support those SQL queries, which I mentioned in the question we got earlier. And so I said Couchbase can be deployed anywhere you want to, where and how you want to do it. So your own private cloud or data center, bare metal, VMs, Kubernetes, what have you. Public cloud, again, VMs, Kubernetes. DBaaS, so Couchbase Cloud is a fully managed offering for Couchbase in AWS or Azure, with more to come in the future, but right now AWS and Azure. And which one of these you choose is completely up to you. And you can also run a hybrid approach. You can have all 3 of these if you want to, and sync the data between them. Have a multi-cloud strategy if you like to go that way. This is the XDCR I mentioned, the synchronization between data centers. One thing that Couchbase does really well, and it's not just XDCR, but and everything that Couchbase does, synchronization is something that it does really, really well. But in this case, we're talking about synchronization from multiple data centers. So you can have US, Europe, and Asia, and they can all sync between each other. They can all be active replicas. They can be 2-way, 1-way, whatever you want to do. You can use this for data recovery, for geofencing, for just reducing latency, having a data center close to, European customers, for instance. This has been in Couchbase for a long time, but it's one of the top things that users and customers love about Couchbase. And so we're keeping that as something that's a core competency, and we're keep trying to make it more and more flexible and more valuable as we go. All right, so migration. So let's say you are facing this kind of problem here. This is the scenario your organization is facing right now. Maybe yours is, maybe it will in the future. But this is something where you have an existing application on a relational database. It's working fine, but maybe there's new changes coming, or maybe there's changes being thrust upon you by world circumstances, and now you have new demands and needs in terms of scalability. So therefore, you're going to explore a NoSQL database like Couchbase as an option for at least some of your workload, maybe all your workload. So these are the multiple approaches to migrating. These are the factors you consider with any sort of migration or change in technology in general, right? So how risky is this going to be? Does our team have the skills to work with this new database? What's it going to cost? Is it going to be fast enough? Is it going to meet our goals? And can it handle increased scale, increased load? And so this is a list of some of the more typical options for database migration. And I've kind of mapped it out here to risk and effort. Now this isn't necessarily discrete, it's kind of a spectrum, right? But the top one there, the one that takes the most effort and the highest risk, is a complete rewrite. We're not going to really do a migration, we're just going to write the whole thing over to use NoSQL. Now this isn't always a bad idea, right? It's high effort, high risk, but it does give you the chance to take advantage of as much of the NoSQL capabilities as possible. And so you can really build it just to use NoSQL. All the way down there at number 5 is one that is maybe less common, but it's something that we're working towards with most recent versions of Couchbase, is try to give you the ability as much as possible to just kind of lift and shift your data out of relational over into Couchbase for maybe a proof of concept, or just to, just for convenience to get you started in the right direction. That's going to be a very low effort, low risk migration or synchronization, but it isn't necessarily going to give you all the benefits of a NoSQL database right away, but it will get you kind of closer to that at least. So, and then what you can do from there is you can start to, okay, we've already lifted and shifted it, let's go and try to optimize it. Now we'll go up to step 4 and so on. So you can kind of ease your way into it. Again, this might just be for proof of concept, but it gives you a easier way to get your foot in that door, basically. So I'm going to talk about that number 5, that low level, low effort, low risk migration, which I'll call migrating without denormalizing. Now, what do I mean by without denormalizing? So in a relational database, data is heavily normalized. That's just the way you store data in relational databases, and you join it together when necessary. So I like to use a paper shredder metaphor, maybe like the cheap paper shredders that shred into little strips, right? So it's not cross-cutting or anything, it's just the strips that it's shredded into. And so I fill out, let's say, a tax form on a piece of paper. Now, in order to store that tax form, I run it through a shredder. So it slices it up into individual pieces, maybe my name into one, my address into another strip, and then my income or different line items into their own strips. And then I store those strips in their own folders with some sort of reference to the my name or my social security number or something like that. And so then when I want to look at or change that form, I have to go through each folder, pull out the shreds, line them up on my desk, and look at the form. I can make changes to it or whatever. The difference between, so that's how I think of a relational database and how you store data in a normalized fashion. Now, a JSON document database like Couchbase does not need to put the form through the shredder. In fact, a document database is going to perform better by keeping those shreds together in the first place and not shredding the document. However, if we're looking at migration, the easiest option, back to that number 5, the previous slide, is to keep them in that normalized state, because our data is already shredded up. So let's keep it in that state, at least to start with. And then we can start, combining them back together. And then metaphor kind of goes off the rails there, because we can't really, rebuild a piece of paper. You have to tape it back together. But that's a metaphor I like to go with, is the shredding. So in a relational database, you have tables. We covered this earlier, and those have rows. In Couchbase, you have collections that contain documents. And this is just kind of the Google Translate version. So I've got 2 rows on the left and 2 documents on the right. 2 rows in a table and 2 rows in a collection. This is kind of a good place to start. So I can take the primary key of that row, blue 123-4, and make that into the document key. So it's kind of a similar concept there. Each document has a key, and each row has a key. So you can take the other values, age, name, and admin, and put those into a JSON document. And do the same for the second row of the table. Now we've got 2 documents in the collection. All right, so we've got Blue Betty, or Betty Blue, and Oscar Orange there in 2 different documents. Now, just to take a quick look at what denormalizing would actually look like. If we didn't leave the data like that, if we wanted to consolidate it and really take advantage of a document database, we could consolidate data like this. So on the left there, we have 3 tables and 4 rows of data. So 4 pieces of data. On the right, we just have the 1 document. So the left is the shredded version and the right is the intact version. And because it's JSON, we can actually have a sub-document like under a nested object under customer and a nested array of objects under items in JSON data, and just put them all together into one piece. Then we can avoid joins. We can avoid ACID transactions when dealing with this data. And additionally, this is just 1 piece of data we can cache, as opposed to 4 pieces of data in 3 tables that can be read and written to and from a cache very, very quickly. So that's one of the benefits of denormalizing. But we're not going to, getting from relational to that takes a lot of additional work and thought and modeling exercises. So that's something we might want to get to later in the long run, right? To improve performance and better take advantage of Couchbase's architecture. So once we've gotten those shreds over, we can then start to selectively denormalize when it makes sense to. So you can have your data storage align with the object model in your application. Typically if you use a tool like Hibernate or Entity Framework or any sort of ORM, that's to address this problem of the data being shredded up, that impedance mismatch. With our denormalized data, the consolidated JSON data, we don't need to spend those resources on joins and transactions and ORMs. But that being said, Couchbase does support them, joins and transactions. So storing that denormalized data is going to make the operations really quick, and memory first architecture I mentioned. But even with your data denormalized, you can still read and write it with SQL queries and indexes. So either way, you get flexibility, right? But we're going to start with the easy path of just sort of lift and shift, and then work towards this denormalized path. So here's a quick example. So I mentioned I'd show some SQL earlier on. Someone had a question about indexing and missing fields. But here on the left is an example of a SQL query for a relational database. I believe this is maybe Oracle or MySQL. It doesn't really matter. But that's a query there that returns a list of all the landmarks that are in the same cities as major airports, right? So if I'm traveling to San Francisco, what are the major landmarks in San Francisco? On the right side is Couchbase's query language. It's a SQL implementation. It's called NoEQUAL, N1QL. And the syntax is going to be largely the same. The main difference is that instead of selecting from a catalog schema table, we're selecting from a bucket scope collection. And it's the same query. As I mentioned earlier, a scope and a collection are not the same thing as a table and a schema, but for our purposes, for querying purposes, it's roughly the same thing. So yeah, this is what I was pointing out there. Table is kind of like a collection. So a collection does not have a defined schema that data must adhere to. So you have some flexibility there. But everything else you'd expect from SQL, joins, merge, common table expressions, CTEs, subqueries, unions, insert, update, delete, everything in there is in SQL. So we often call this language NoEQUAL. We often call it SQL++ because it's SQL plus some extra things to deal with JSON, some NoEQUAlisms, I guess, that do things like unnesting and nesting to deal with those embedded documents, right? The nested objects, the nested arrays, some extra syntax. We already mentioned the missing. That's also some extra syntax. So that's one of the pluses in SQL++. So I'm not going to go deep into indexes, but creating an index in Couchbase is just kind of like the same thing as creating an index in a relational database. You have create index, you give it an index name, you give it a collection you want to index, and then the fields, the JSON values that you want to index on. Now this is called a GSI, a global secondary index, because they're not stored alongside the data, which actually gives some performance benefits and some workload isolation benefits to the query language. So it doesn't have to necessarily touch every single machine in your cluster to run this query. It'll go to one global index, and then it can fan out as it needs to. And in some cases, you may not even have to access the data. You can create what's called a covering index, and all you need to return from the query is already stored in the index. So even faster, you can skip the next step of actually performing the lookups. So just to kind of sum up here, the keys to success in this kind of migration is, these are the important factors. So does our NoSQL database have the features that we need to support this kind of lift and shift, specifically SQL, so we can run the same or similar queries, ACID transactions, because our data is still split up into parts, and joins to join those parts together. We got to understand how data is organized between buckets, scopes, and collections, and how that kind of maps to our existing relational model. SQL dialect, so sometimes the query may work as is, sometimes you need a few minor tweaks, and sometimes you might need a major tweak in a keyword. And then we can always think about optimizing later. So as long as we get the data over and the queries to start working, then we can think about, is this meeting our performance goals? If it is, then maybe we're good. If it's not, then there's things we can do to consolidate data to make it even faster. And I guess I didn't mention that there is still in Couchbase security at each level that's good for microservices and multi-tenancy. So you need to have those considerations in there as well. I need to set up users that have limited access to scopes or collections or what have you. Same kind of concepts apply. All right. So once we got that data shifted over, we need to think about how we're going to optimize that data. What are the next steps once we've done that lift and shift of data? So joining and transacting is more costly than not, especially in a distributed architecture. And it doesn't scale as well horizontally. So we might need to think about reducing the amount of those joins and acids. Although again, it's not that we can't use them, it's just that we may not want to use them as much to hit performance goals. We can use our existing application code as a guide. So if we're having a Java application or a C# application and there's a person object and that person contains addresses, but it actually has to go and look up the orders in the application. So we can think of that as like an entity within the application, and that's maybe how we start to think about mapping the data in our database as well. So what in the scope of my application, does this have a life cycle outside of the thing that always references it, right? So is address something that is used outside of the person? If not, there's no reason not to just attach that to the person as an object. So, but ultimately we want to think about, can we reduce the number of transactions? Can we reduce the number of joins? And by doing so, have we met our performance requirements or scale requirements? So we want to keep those in mind as we do. We don't want to just consolidate data because we can. We want to make sure that it's going to give us the benefit we want to when we do that. Otherwise, leave it as it is and keep going. So here's a hypothetical to kind of illustrate. So let's suppose a user has a checking account and a savings account. These data models, by the way, are probably not ones I'd recommend for production, but it's just for illustration. So in a relational database, we have, let's say, 2 rows of data, maybe 2 tables or whatever. And so in order to transfer from savings to checking, we have to have a transaction. We update one piece of data, we update another piece of data that's separate, and then we commit the transaction. If those were in the same row of data, right? If I had a savings column and a checking column, I would not need a transaction. I could just have one update statement that would be atomic in and of itself. And so that's the same approach you can take with a document database. Is I can have a single document that has a balances object, a nested object that has savings, checking, whatever else, money market, etc. So I could model it that way. And then it would just be a single update statement to transfer between those accounts. Now the difference here is that in a relational model, creating columns is not a trivial operation. Changing the schema is not always very trivial. With a NoSQL document database, there isn't a schema that we have to abide by. So we can add additional balances to that object without having to go through and actually modify the database. So again, I don't know if this savings and checking example is ideal for a banking system, but it's a good example because people understand transferring money between accounts. Okay, there's a question came in. What would happen in terms of query order in an atomic document update if a debit and credit were applied to the same balance field? Same balance field. Query order in I don't think I quite understand that. They're applied to the same balance field. So if they were both applied to balance.savings, I don't know. That's a weird one. You'd update it, update like set balance.savings equals 100 and balance.savings equals 200. That would be, I don't know what would happen there. That would be a little odd. That might even be an error for all I know. I'm not sure. Let's see. How do you manage typos such as savings with 2 V's? Yeah, that's probably a little more detailed question, but yeah, I would probably, if you were concerned about that, I'd probably try to make that as strongly typed as possible in my application, so that it's not me typing in strings into the code, but I'm actually using a model, and that's being serialized automatically there. But it is I guess the question would be, if I make a typo, is it the query is still going to run, right? Because it's flexible. One thing with Couchbase actually is if you run this directly in like the query analyzer tool, which I'm actually going to show later, so maybe I can demonstrate this if we have time. It's actually going to say, hey, are you sure you didn't mean savings with 1 V? Because I don't see any savings fields in there. It'll still allow it, right? But it'll show an error message or a warning message at least, saying, hey, maybe you didn't mean that. All right, so I want to think about modeling a little bit here before we get into the demo. So the key element of optimization here is to determine where and how you can consolidate your data. So from those shreds into a whole. So let's look at a diagram of a more complex sample here. And what I'm thinking of here is, if you've ever read the book Domain-Driven Design before, I'm thinking of entities as a kind of an aggregate root. So a sort of the highest level where a piece of data makes sense on its own. So in this model, orders contain items. So we can just switch to embedding the items into the order itself. This is one thing. This is one consolidation, one optimization we could pursue. Or maybe there's another alternative, and this is just going to depend on your use case and how you're reading and writing data, how you're accessing data, what makes sense for performance. We could group them together differently. We could have pay type inside of the order, and instead of embedding the items, we can embed the product into the items. And this might make sense if you want to take a snapshot. I don't know about you, but sometimes when I look back over my Amazon history, there are items that are no longer available for sale, but I can still go back and view my order and see details about the items. So maybe consolidating those into like a copy or whatever, maybe that makes sense for your system. And this is how the JSON would look there. So only the quantity and discount are embedded in the order, but the items and the product are now grouped together. So that might be the way you want to go about this. Another consideration is whether to use an array or nested object, or even an array of objects. So the way you work with these two options can vary. So you'll need to know how you plan to access the data. So for instance, does the sort order, is that important, right? In this case here, we've got phone numbers. So I can have multiple phone numbers. Do I need to sort those by the date they were verified, for instance. If so, then arrays might be the way to go. But if I need to update, often update phone numbers on an individual basis, then nested might be more efficient to do that. I can just go and directly hit phones.home and change that instead of having to navigate the whole phones array and maybe rewrite the whole array. So, those might be small optimizations, but those can add up over, thousands, hundreds of thousands of operations. So here's kind of my conclusions. Make sure to migrate first, optimize later. This is, the start at the 5 and move your way up towards the 4 and higher. Joins are more costly, distributed architecture. So think about a one-to-one migration. It might be slower, it might require more hardware, but that's something you really have to measure based on your queries and your use case. Embed documents to optimize when you can. This is one of the benefits of a NoSQL database. Queries can be converted from whatever relational database you're on. They can be converted over. Sometimes they can run as is. That's nice if that happens, but sometimes it takes a little tweaking. ACID is available. Only use it when you have to. And make sure throughout this whole thing, you have some scale and performance goals. And are we meeting those goals or not? And so we can explore different routes. There's lots of different options we can take, lots of flexibility. But ultimately, we want to keep a performance goal or a scale goal in mind. SQL queries can be converted. I mentioned this. It's not as bad a process as you might think, depending on how complex your queries are. If you're thinking about reporting queries or BI queries that are very, very complex, that might be better off in an analytics setting than what we're looking at here, which is kind of an operational setting. But as I mentioned, Couchbase's NoEQUAL is a full SQL dialect with joins, unions, and merge, all that good stuff. And based on user surveys like the one here on the right here, it's one of the top reasons that people choose Couchbase over other NoSQL competitors is because they can write SQL, which is a very declarative, concise, and well understood way of working with data, as opposed to learning a whole new language, which is time consuming and just kind of harder to wrap your mind around and harder to ramp up and be productive with. Okay, so I've got a little bit of time here for a quick demo of Couchbase in action, if you all don't mind. This won't take that long, I don't think. I've got Couchbase 7 currently running on my local machine. This is currently a beta release, but it's a public beta release, so you can all download this if you want to try it yourself. Couchbase.com/downloads. I've got, these are my buckets. I have one bucket of data here. I'm going to go ahead and add a sample bucket. My favorite one is travel sample. I think we're all missing travel these days, hoping to get back to it here very soon. So I like to use the travel sample data. So that is a bucket here. It's going to be loaded with some sample data. It's going to take a few seconds here for that to load up. But this is the bucket level I was talking about. So each one of these roughly corresponds to a database in a relational system, like SQL Server calls them catalogs. This kind of roughly corresponds to that. So rule of thumb is roughly like, this is at the per app level sort of thing. This is a high level of organization. You can have multiple buckets in a cluster, and each bucket can have its own memory quota. So let's see if I can zoom in here and show some of that. So this bucket quota is 200 megabytes of RAM, so it's a built-in cache. So anytime we access data from this, it's going to look for it in memory first and pull it from that cache. If it's not in memory, it'll fall back to disk and pull it into memory and then return the value. So it's a built-in caching layer there. Let's see. I have to bring my notes up here. So what I wanted to do is show, I should have done this before, but I wanted to kind of drill into these buckets, and just bring up my notes here, just make sure I'm covering everything I wanted to cover. Okay, so I'm going to go to travel sample here, and notice this scopes and collections option right there. So inside of this, you can see that there's multiple scopes. These may correspond to tenants if you have a multi-tenant system you're building, or they may correspond to a microservice. So if you want to separate services by person, invoice, whatever, you can have a bucket for each one, for instance. And role-based authentication is available at the scope level. So you can give users permission to certain scopes and not to others. Question, how large can databases in Couchbase be? Many terabytes, many petabytes. I would say Couchbase right now, I think it's safe to say probably in the terabytes range. I think we have some customers in the terabytes range. We are working on some things to up that so it can be a higher amount of data in a single cluster. I will say that because Couchbase has really good synchronization, we have many customers who are absolutely running multiple Couchbase clusters together. So they may be big enough even to have a cluster per microservice, for instance. But yeah, that's a really good question there. So click on inventory here, and this will show a number of collections here. And again, role-based authentication is available at this collection level 2. So I'll click on routes next, and I'll click on documents next to route. And these represent airline routes from one city to the next. And these are all documents, so it's kind of like a row in a table, and they roughly correspond to rows in a table there. So if I click on one of these, let's click on route 10,000. We can see that unlike a rows, we can have some nested data here. So you see I've got this schedule array that contains, a day and a time and a flight number that flies along this route. And it has a source destination and a destination airport. So each route has a source and destination airports that it goes to. So that's what that's a document there. You can see we're taking advantage of JSON by having some array of schedule there, but other than schedule, it's all pretty straightforward, relatively flat data, except for that very handy routes array. So let's go back over to query next, and I'm going to paste in a query here. And let's zoom in a little bit so you can read this. Not a terribly complex query. Well, we're just going to select everything from a route where the source airport is Columbus. This is where I live, Columbus, Ohio. So these are all the routes that leave from Columbus. So you can see here we've got one from Columbus to Atlanta, and here's the schedule, and there's another one to Los Angeles, and so on. We've got a total of 63 routes that leave from Columbus, Ohio. That's just an example of a really simple SQL query that I'm running on NoSQL JSON data. Let's get a little more complex here. Notice the airline ID field here. This tells us which airline this route is for, but it doesn't really tell us the name of the airline. We can't very well say airline 321 to the customer. They don't know what that means. So we're going to have to do a join to get that airline name, because the airline name is in a separate document that has a key of airline 321. So there we go. This is, I just want to save you from watching me type this all in, but it's the same from, now we're joining it to the airline collection. Looks like you got a typo here, whoopsie. That's going to join on airline ID, and this should be equals. My goodness, who QA'd these queries? It was me. That's going to join to the document ID. This is another little nicklism here. This corresponds to the document key, the document ID. And so this is, again, the ones that have a source airport of Columbus. I'll execute this, and thank goodness I caught those typos. But now you can see this route here goes from Columbus to Atlanta. It's airline 2009, which we know from the join is Delta. Makes sense, a lot of Delta flights out of Columbus. We keep going down, more Delta, more Delta. There's AirTran, this is kind of an older data set, and so on. American Airlines, there you go. So that's just an example of a familiar relational concept of joins, but we're querying over a distributed document database. And I say distributed, even though this is just one node running on my local machine, but if this were in production, you'd see a list here of all the different servers that this is running on. But from a developer's point of view, I'm issuing a query to a cluster, and the cluster is handling all the distributed parts of working with that data. Okay, that's the demo I've got. And I think that's just about it for me. One more thing I'd ask you to do, if you're interested in Couchbase here, we actually have a cloud, Couchbase Cloud, which is a database as a service. It's a fully managed database offering. we have a free trial going on right now. This can actually be deployed to either Amazon or Azure. It deploys in your VPC or your VNet, depending on which of those cloud providers you're using. And you go check it out, couchbase.com / well, I think /cloud should work, but /product /cloud will take you there, and you can sign up for that free trial if you're interested. Okay, so I think that's all I've got. Is there any more questions that I haven't covered yet, or anything else we can talk about?
There are a few more
Okay.
questions coming in. So we'll go ahead and get to those. The first of those being, does Couchbase offer consulting to assist with migrations?
Yes, absolutely. So, this kind of migration, if you're not familiar with NoSQL, you may think it's a little bit, maybe a little bit scary at first, but certainly we're trying to build tools and partnerships to make that easier for you. And absolutely, we have solutions engineers and or professional services that can help walk you through this process along the way. So if you're interested in just exploring it, for that matter, making a proof of concept, get in touch with us, and we can get a solution architect out to you to talk about how or why you'd want to go through this process, what your use case is, and those kind of things. So yes, absolutely.
Well, that sounds super helpful for getting that migration to work, just like someone may need it to. Okay, another question we've got here is, can Couchbase handle blob data for content management?
So blob data for content management. So I think if we're talking about binary data, you can absolutely store binary data in Couchbase as a blob. It can work as a generic key value store. I will say though that Couchbase is not meant to be S3, for instance. So if you want to store large pieces of large binaries, for instance, you might want to use Couchbase just for the metadata and not for the actual binary data itself. But it can, and many of our customers and users do use Couchbase to store binaries.
Good to know. Got a few more here for you. An audience question saying, how well can Couchbase search over an arbitrary set of record IDs in a query? For example, hundreds of IDs.
Yeah, so again, it can do this, absolutely. So you can either look those up individually by using key value lookups, or you can provide a list of IDs to a SQL query. I think it really depends on what are you searching by the document keys. Are you searching by some field in the JSON? It's going to depend on, and then are you going to return the entire document, or are you just returning parts of the document? So all those things are going to factor into the performance there. But those are all certainly possible in Couchbase, yes.
Okay, good to know. Another one here is, what is the Couchbase equivalent of a stored procedures in an RDBMS? Can it run various programming languages?
Okay, so I get this asked every once in a while, and stored procedures are kind of controversial sometimes, depending on where your background is. But so Couchbase doesn't have something called a stored procedure, at least not yet. What it does have is other ways you can create and define functionality at the database level. So Couchbase 7, I believe Couchbase 7 upcoming will have user-defined functions. So you can create a function, and you can create that with the NoEQUAL, with SQL language that I showed you. And I believe, I'm not 100% sure on this, if it'll be out in 7 or not, but I believe you can create them with JavaScript as well. So depending on your use case, JavaScript may be a better fit for some bits of logic than SQL. If you have a heavy case statement, for instance, you could do that. And as far as other functionality, Couchbase also has an eventing service. So if you want to write, and this would be JavaScript, if you want to write JavaScript functions that respond to changes in data, so updates, adds, deletes, you can write events that respond to that and then perform some logic or behavior. I believe that's just JavaScript, although I think you can embed SQL in those. So again, kind of a hybrid there of SQL and JavaScript. Good question though.
Nice. And it looks like we've got time for 2 more questions.
All right.
One of those being, if I want to propose Couchbase to my director, what are the main benefits of switching from SQL Server?
Yeah, so I guess it would really depend on what are your pain points with your current SQL Server deployment, right? If it's currently humming along just fine, then I wouldn't propose replace it just because. Couchbase is cool stuff, but you have to have an actual business benefit to switch. So I would say the main benefits of Couchbase um, is generally speaking, it's going to be the scalability, right? So it's much easier to scale up than a traditional uh, relational database. You can scale a relational database vertically, put it on a more expensive machine, for instance. But with Couchbase, you can actually scale horizontally, add multiple nodes to the cluster, and that's an efficient way to scale out. It's a built-in caching layer, so you'll probably get lower latency, depending on your use case. You're going to pull data from memory more often than not, and then having to wait on going to disk. You're going to get high availability as well. And this comes from the distributed nature of Couchbase. High availability means that if one of the nodes goes down, the other nodes will still be online and they will keep the system running. Whereas a traditional SQL Server model, you may have a backup system or something, but Couchbase, that's high availability is built in. It'll keep reading and writing even if one server goes down. And SQL Server, if you don't have like a replica machine or something, if that server goes down, then your system goes down. So those are some high-level benefits. Couchbase has a mobile database that can sync automatically with it, as a built-in full-text search engine, built-in analytics engine. And I think one of the things, especially because you're coming from SQL Server, is that Couchbase still has familiar SQL language. So compared to other NoSQL databases, you're going to spend less time learning how to query data in Couchbase because you already know how to write SQL.
All good points. And then our last question for today is, what free resources are there for developers to get started with your NoSQL?
Yeah, so if you're a developer interested, definitely check out developer.couchbase.com. We've got lots of great material there. If you want to learn more about the language I showed you, NoEQUAL, which is just a SQL language, we have some interactive web-based kind of tutorials or guided tours of the language that you can play in a sandbox. We have some sandboxes available at couchbase.live. So you can actually write some Java code, for instance, and interact with Couchbase there. If you want to tweak an existing example and run it, you can do that at Couchbase Live. Certainly, I mentioned Couchbase Cloud. There's a free trial right now. You're going to use your own AWS and Azure resources, but you can use Couchbase's service on a trial basis for free right now.
Amazing. And we are out of time, and I see there are some questions that we didn't get to. So for those of you who didn't have your questions answered, we'll make sure that Matthew gets them, and he'll be able to reach out to you individually.
Absolutely.
Perfect. So with that, DZone would like to give a big thank you for Matthew for that phenomenal presentation. DZone would also like to thank Couchbase for providing the audience with a great webinar. Lastly, thank you to all of you who attended today. We hope you learned something new that will help you in your developer career. Have a great day, everyone.
Thank you.